Welcome to the deep dive. Today, we're really getting into something interesting. Gemma 3270M. It's this AI model that's kind of proving a big point. Tiny models can have a huge impact. For the longest time, it felt like the whole industry was just chasing bigger and bigger models. But this deep dive, well, it's going to show you how sometimes a smaller, more specialized approach is actually incredibly powerful, especially for real products. So our mission today is to unpack how this compact model really punches above its weight, you could say, and why that matters so much for the tools you use and maybe for those of you building them. I mean, the core promise is pretty amazing, right? Answers in milliseconds, privacy built in, and costs like less than your coffee to run.
Yeah, and that cost and speed point it's really not trivial. Gemma 3 isn't just some, academic exercise. It feels engineered fundamentally to be the backbone for products, stuff that needs to work reliably, like anywhere. Even if you're offline, airplane mode, whatever. Think about what that unlocks.
Right.
AI, that's just there.
Rocco.
Right in your pocket.
Okay, let's unpack that a bit more. We've all heard that mantra, right? Bigger is better in AI, but you're saying these tiny models like this Gemma 3270M, they're actually winning out more and more when real users are involved.
Yeah.
What's the shift there? Why are they winning?
That's a great question. Because, yeah, the huge models, they get the headlines, they need massive compute. But when you actually ship a product, what matters? Latency, battery life on a phone, the actual cost per user action, and critically, data privacy. Most tasks in production AI aren't, write me a novel. They're very specific, like classify this support ticket, pull the vendor name from this invoice, wrote this question, that kind of thing.
Oh, okay, so they're scoped.
Exactly, well scoped. And for those jobs, Gemma 3270M just hits the sweet spot. It slashes your cost per request. It really cuts down that tail latency, the annoying delays that users sometimes hit. That gets way better. And crucially, you can keep the data right there on the device. It never has to leave.
That on-device part really clicks for me. I read about an internal test, something like 25 short chats on a phone, and it barely touched the battery, like 0.75% using INT4. Could you maybe explain INT4 quickly for our listeners?
Sure, yeah. INT4 is basically 4-bit integer quantization. It's a way to compress the model, make it much smaller in memory and faster, and often, especially with models designed for it, without losing much accuracy for the specific task. And yes, that battery test, that's not just a small improvement, it's a leap.
So what does that actually unlock, practically speaking?
Oh, it's huge. It means real freedom for developers. You can build tools that work offline reliably. Think apps on a plane or in areas with spotty connections. Features that were just impossible before because you couldn't rely on the network or because sending the data to the cloud was a non-starter for privacy reasons. Imagine drafting sensitive emails offline or a notes app that organizes things privately, locally. That's the kind of thing.
Okay, so small models are becoming key for certain applications. Let's get specific about Gemma 3270M itself. What is it exactly? Is it just a shrunken big model, or is there something unique in its architecture?
It's definitely part of a family, the Gemma 3 family, all with open weights, which is important, and a very practical design philosophy. The 270M is the smallest, yeah. But it's not just scaled down arbitrarily. Its architecture has this interesting split. It puts a lot of its parameters, about 170 million, into a really large vocabulary, 256,000 tokens. And then the actual transformer blocks, the sort of thinking part, use the remaining 100 million or so.
A big vocabulary. Why is it important for a small model?
Because that helps it handle the messy reality of real-world text. Think about rare words, product names, jargon specific to an industry, people's names. Smaller vocabularies often just break on those. They see them as unknown. This large vocab helps it cope much better.
That makes sense. Targeting real-world data issues. You mentioned versions. It comes in different flavors.
Precisely. There's the base pre-trained model, kind of a blank slate, then an instruction-tuned version, which is already pretty good at following commands like classify this or extract that. And then there's a QAT release, quantization-aware training. That one's specifically trained to work really well, even when it's compressed down to that INT4 format we mentioned, vital for running smoothly on devices with limited memory.
Okay, QAT for on-device. And capability-wise, what can it actually handle? You said it has a context window.
Yeah, a 32,000 token context window, which is, pretty decent. It's not going to analyze War and Peace in one go, but it's plenty for looking at a short document, maybe a user agreement, a web form, a few chat messages back and forth, maybe with some tool outputs included. Again, the goal isn't encyclopedic knowledge. It's shipping a feature, an instant private feature. So best tasks, classification, extraction, routing, formatting data like into JSON, and those lightweight focused assistants.
It still feels a bit counterintuitive, though. How does something so small get so good at these specific things?
That's where the specialization comes in. That's its superpower, really. Steerability and cheap fine-tuning. You don't need a million examples in a giant GPU cluster to fine-tune Gemma 3 270M. What you need is a tight spec. What exactly should it do? What does success look like? Then you need some good examples, especially the tricky edge cases. And a feedback loop. When you fine-tune it on that specific job,
It becomes a specialist.
exactly, a specialist that often creams the big generalist models on that one task. And it does it while running on, pretty basic hardware. That's the compounding effect. That's how you go from a demo to a reliable system people actually use. Libraries like TRL Transformer Reinforcement Learning make this tuning process even more accessible to.
Right, TRL helps streamline that. So, okay, you've tuned it. What about performance? Benchmarks aren't the whole story, but they give us a hint, don't they?
They do. They help set expectations. And the instruction tune 270M actually does pretty well in things like IFEval. IFEval, for listeners, it measures how well a model follows specific instructions and formatting rules, like output JSON with these exact fields. The fact that it scores well there suggests it's good at sticking to a contract, holding a specific output shape, which is exactly what you need for reliable features.
Okay, so given all that, when should a team really reach for Gemma 3270M instead of, say, a bigger model? What are the trigger points?
Definitely pick it when predictable low latency is key. When privacy is non-negotiable, got to be on device. When your cost model needs to scale to potentially millions of calls without breaking the bank, it's the obvious choice if you know you're going to fine-tune it for a narrow task extraction, compliance checks, smart routing, that stuff. Mobile users are a huge one. If the network's unreliable or privacy rolls out the cloud, on-device is your answer. Also, if you're building with microservices, having a small, dedicated model per service, it composes really well, makes systems cleaner. And finally, speed of iteration. Need to experiment fast. Small models train fast.
So it's about matching the tool to the constraint.
Precisely. Broad knowledge needed. Go bigger in the Gemma 3 family or look elsewhere. Need precision under tight constraints. Start with 270M and specialize.
That's super clear. And for the developers listening wanting to try it out, you said it's quite portable, easy to run locally.
Oh yeah, very much so. The ecosystem's already quite good. You can grab it with Ollama really easily for a quick local API. Great for playing around, prototyping. Need more performance, maybe on the edge, or just a laptop. llama.cpp and gemma.cpp ports are excellent. Run tight on CPUs, even small GPUs. If you're in Python, Hugging Face ecosystem has you covered. Models, tokenizers, training tools like TRL on Apple stuff. MLX is a great option, makes it easy to use the hardware well on Macs, iPhones for prototyping. And if your team uses TensorFlow serving, Keras makes it straightforward to set up an inference service.
Wow, okay, lots of paths and in. So, quick developer checklist. What are the must-dos when starting?
Right, essentials. 1, accept the license, obviously. 2, pull it with Ollama or your preferred tool for quick access. 3, critically measure latency, but use real inputs, stuff that looks like your actual production traffic. 4, think about quantization like INT4, only after you've checked if the compressed model still performs well enough on your specific task. Don't just assume, measure. And 5, log everything. Prompts, outputs, especially any schema errors, you need that visibility.
You mentioned microservices and composing models, and you brought up this idea of a fleet model. Can you expand on that? It sounds powerful.
Yeah, it's a really clean architectural pattern, I think. And Gemma 3270M makes it practical. Instead of trying to build one giant AI brain to do everything, which gets complex and expensive fast, you build a fleet of small specialists. So you could have one tiny Gemma 3270M checkpoint whose only job is intent classification, another just does JSON formatting, a third handles PII redaction, maybe a fourth does some very light scripted assistance. The benefits are pretty clear, right? Each piece is cheap to run, cheap to test independently, easy to update or replace. It lets you specialize much more granularly, even on tight budgets, opens up AI for way more use cases.
That's a really compelling way to think about building systems. Okay, another comparison point people might be wondering about.
Sure.
5.4, Microsoft's model, also aiming for that compact but capable space. How does Gemma 3270M stack up against 5.4?
Good question. They're both pushing that usable, shippable AI idea, but they are different beasts. Gemma 3270M, as we've said, is your tiny hyper-specialist, ideal for local, on-device, latency, privacy, cost, or its domain. Classification, extraction, strict formatting. 5.4 is, well, quite a bit larger. It's a 14 billion parameter model trained on vastly more data, almost 10 trillion tokens. It's primarily English. It's had supervised fine-tuning, preference optimization, safety testing. So you'd expect 5.4 to be stronger out of the box on, say, zero-shot reasoning, maybe math, code generation. It has more general capability. But it needs GPU inference. It will have higher latency than Gemma 3 270M.
So again, trade-offs. Choose based on the need.
Absolutely. Need more complex reasoning, handling longer inputs, richer tool interactions, and you can serve from a GPU. 5.4 could be a good fit. Need that extreme low latency, on-device privacy, or you're doing very specific fine-tuning. Gemma 3270M is likely your starting point. The real answer, though, measure. Try both on your task if feasible. Compare accuracy, latency, especially that P95, and cost. Let the data decide.
Okay, measure, iterate, makes sense. So once you've picked a model, started tuning, how do you make sure it actually works reliably? Evaluation sounds critical, maybe even more so for these specialized models.
It's paramount. And you need the right kind of evaluation. Don't just reward cleverness. You need evaluation that checks if the model fulfilled its contract. Use explicit schemas. Parse the output. Fail hard if it doesn't match the schema. No excuses. Track accuracy for your task. Exact matches for labels. Correct entities extracted. Whatever matters. Track stability after quantization. Did INT4 mess things up? You need to know. And log latency distributions. That tail latency, the P95 or P99, that's user experience. Don't just look at averages. And don't forget a small human review loop. Catch those plausible but wrong answers automation might miss. Benchmarks. Good for initial feel. Contracts. That's what ships reliable products.
You mentioned a clean starter plan earlier. Get Gemma 3 into production in about a week. That sounds almost too good to be true for AI. Can you walk us through that again?
Yeah, it's ambitious but doable if you're focused. Step 1. Pick one narrow, painful, repetitive task. Something concrete. Step 2. Get maybe 200 real examples, reflecting actual production data, warts and all. Step 3. Define a strict JSON output schema. What fields? What types? Maybe confidence scores. Step 4. Run a baseline using the base instruction-tuned Gemma 3 270M. Log schema errors religiously. Know your starting point. Step 5. Fine-tune it, maybe using TRL on your data. Keep a validation set with tricky edge cases separate. Step 6. Quantize to INT4 QAT weights if you need the speed or size reduction. Test it again. Step 7. Canary deploy. Start small in production. Reject any output that violates the schema. Be strict. Step 8. Collect failures from production, add them to your dataset. Retrain regularly, maybe weekly. Step 9. 2 beach boards. One for system health throughput, latency. One for semantic quality error rates by field. See? The model's just one piece. It's the process. Gemma 3 makes the process faster because it's small and easy to steer.
That's a really practical roadmap. Okay, flip side. What are the common mistakes? The pitfalls to absolutely avoid when working with these models?
Oh, there are a few classics. Number 1, don't try to patch model errors with complex rejects downstream. Fix the data, fix the fine-tune. Don't paper over cracks. Number 2, don't just measure average latency or accuracy. Averages hide the pain points. Look at distributions, percentiles, especially the tail. 3, don't keep prompts secret. Document them alongside your schema and examples. Treat them like code. 4, instrument early and often, log everything. You can't fix what you can't see. Don't wait until it's broken. And 5, please, don't chase leaderboard scores on benchmarks that have zero relevance to your actual product's function. Focus on what matters for your users.
Solid advice. So, boiling it down, if you had one simple mantra for success here.
Maybe. Fewer prompts, more contracts. Fewer debates, more experiments.
I like that. So wrapping up, Gemma 3 270M really feels like a shift, doesn't it?
Yeah.
Less about the sheer spectacle of AI and more about practical, solid engineering. It's kind of proof that the right model isn't always the biggest. It's the one you can put exactly where you need it, the one you can shape to your exact needs, your schema, and trust to answer quickly without, firing up a whole data center.
Yeah, absolutely. It's small, it's portable, it's steerable. It's a quiet workhorse, something you can actually integrate deeply. Pull it with Ollama, train it with Hugging Face, deploy it, get real impact.
So maybe the final thought for everyone listening, as you think about this, what's that one specific repetitive task in your own day, your own work? Could it be transformed by a specialized little AI running right there on your device, keeping things private, giving instant answers? And maybe stepping back, how does this idea of a fleet of specialists change how you think about building intelligent systems? Moving past the one AI to rule them all idea, maybe the next step isn't another debate, but actually grabbing a test set, define a schema, and shipping something your users will feel immediately.